Okay, yeah. Welcome, guys. Settle in. So, yeah, the recording has started. So, the video lectures will be available on Canvas or on the website. I'll probably make it on the website so it's easier so you have everything in one place. I don't like Canvas, so let's not get to that. So, we'll put it on the website. I think it's easier. You can just scroll and you can just click a link and it'll take you there. Okay. And it'll probably be on YouTube as well. So, I'll make a YouTube channel and just post it there. So you have it, and even after you leave WPI, you still have it. Okay, cool. Yeah, so this is my first class at WPI, so that's exciting, right? So yeah, welcome. So I just joined a month ago, exactly a month ago. So we'll talk about me in like a few minutes, but first thing is I want to know about you because the class is about you, not me, right? So I want you to tell me two things. So obviously your name. I'm going to try to learn all your names soon. And the second thing is one thing which you like to do, which is not work.
Something is hard.
Which is not work. Like something for fun. What do you do for fun? Yeah. Learning, you want to start?
Yeah, I was
Hello everyone, I'm studying I will be the TA for this course. And what I normally do besides work, and I like playing like games like League of Legends or Ghost. That's it.
Awesome.
So, hi guys, my name is Vaishnavi. I'm the second year for this course, and what I essentially like to do when I'm not working is
So, yeah.
like to meet you.
Yeah, just keep going this way.
I'm Carter Cheeker, and I like to do some travel and hiking.
Awesome.
Hi, I'm Arya. I like to dance.
Awesome. Yeah. That way. Yes. Yeah.
Hi, I'm Sam. I like kayaking.
So I'm Chris. I like hiking.
Hey everyone, I'm Alex. I like to play soccer.
Hi everyone, I'm Fit, and I like anime.
Awesome.
Hi everyone, I'm Nitin. I like to play badminton. Hello, because I like to play squat.
Hello, I'm Jonathan, and I like playing games as well. Like the game.
Awesome.
I'm Tess. I like painting and other art.
Yeah, let's come to the front, sorry, because we missed you both. So your name and one thing you like to do, which is not work. So something for fun.
I'm Sushmita. I play badminton. I'm Radha. I like to sketch and sing.
Awesome.
And Perivasan, watch TV. I'm activist. I like paint every day. I am Ladit, and I like to cook.
Hi, I'm Raj, and I like to play video games. I also try to connect the badminton on the flick. What's it? I feel pretty fun.
I like getting in love.
I am Adit, and I like to explore the world.
I RBE and it's a J basketball.
Support.
I how it's built in the cat. Like so like.
I can go on chip instead. Alex RBE.
Hi, I'm Pratham. I like to travel around and see our responding places. Hi, this is Adish. I like to travel around and I like to read books. Hi, this is Colin. I like to play basketball. Hi, this is Mayan and I like to work the gym.
My name is Ty. I'm good. I like to read and also. I am on this year and I like to go to the zoo.
And Deepak and I like to meditate.
I'm Anushka and I like to read.
I'm Lois, like drawing.
I'm Uttara. I like to travel and listen music.
Yes.
I would make. I like to. I just chill where I like lying around.
I'm with you on that.
I like to play soccer and stuff. Hi guys, I'm Sean. I'll go on time. Hi, I'm Matt. I like work on cars.
You said you like working on cars? Okay, awesome. I do too. So I built my first V4 engine when I was 18 years old. Yep. Anyway, yeah.
I which sign like
Okay, thanks, Chinmay. I like the just to what you.
I'm Emmanuel and I like reading. So to everyone, with that and I please. and it's plain English touching, and I do writing on someone. I can read.
Bayan, Masita, and affected by an Amsterdam.
My name is Devesh, and I like sketching and moving. Hello, my name is Keshu, and I love to read books.
Hi, I'm Ubrat. I love playing Dota 2. I'm just into some better than you.
Me too.
Hello, I'm Visha. I like read chess and read books. Hello, I'm Subho. I like play video games. Something. I'm Devi. I like playing monkey games. I'm chess. Like that, I like to play Dota. I don't know why I waste so many hours on that.
I have 10,200 hours. Let's not talk about it. Let's not go there. What about you?
My name is Thomas. I like to play the
Awesome. Did we miss anyone?
yeah.
Yeah.
Hi, I'm Ganesh, and I like from Rory, and I said,
Awesome. Cool. I don't think we missed anyone else, right?
hello.
I'll talk about me in a bit, but okay. So please do this. Take your phone out, take your laptop out. I wanted to send an email saying bring your laptop, but you can do it on your phone. Works. So yeah, if it doesn't work, you sort of sadly have to type that thing in the bottom end, but it should work. If you are using Android, if your normal native app is not working, use Google Lens, or on your search bar, you can hit the camera button. If you're using iPhone, it should work out of the box. Yeah, the new Samsungs or Pixels should work out of the box. I don't know about other Android phones. So yeah, if you're using anything else, God bless you.
So thank you.
Yeah, let me know when you're done. I'm gonna wait for you. I'm gonna give you like 2-3 minutes. So it's a pretty short thing. So the main goal of this form is so that I can tailor the course to what you want. And I do have a syllabus in mind, but I would want to obviously also add in things you would want to learn from me. And if there is a majority vote for certain set of things, I will definitely add that in, right? And obviously I want to know what computers you have so that we know how much you can expect like help from us. So that's the main idea. Those are the two things I need to know.
That's it. Then.
And is this the first class that you're like I'm asking somebody's asking you to use your phone?
You know what they're acting?
No?
Actually, I'm like, there's that.
Okay. So technically I'll take it.
The first. Time to get 12 version.
I'm just taking a selfie as you guys are continuing to work. So pretending that I'm actually doing something. So yeah, just let me know when you're done. And if like most of you are done, we can continue. Because this doesn't need much brain power.
Right. Well. What? So.
Do you need more time? I don't know. Is that a yes or no?
Thank you.
Like, okay, does anybody need more time?
We press up.
Or all if you're done? The people who are on your phones, do you need more time? Okay. Like, it's a simple yes or no question.
Going to please.
I didn't ask you the probability distribution of something. This you should be able to answer, right?
Yeah.
That is yet to come. That will come soon. Yeah.
Is acting so. One.
Good. Do you want me to wait? All done? Okay. Okay, so I'm going to introduce myself officially. So I'm Nitin J. Sanket, and my pronouns are he, him, his. And this is how you pronounce my name. Please get it right. So if you cannot pronounce my name, call me N. That works, don't butcher it. So it's simple, it's Nitin. Like there is a silent H. So it's like knitting. Like if you want to remember knitting, it's like that. So last name is Sanket. And yes, I am assistant professor at WPI. I am in the robotics engineering department and the ECE department. I'm waiting for affiliations from CS and aerospace. So soon that list will grow longer. So let's see. I'll give you a brief history of my life so you know where I come from. Okay, so I'm from India, obvious, right? So I'm from the southern part of India, so from Bangalore or Bengaluru, however you want to call it. And I did my undergrad in Ramaya, so MS Ramaya Institute of Technology for people who are from India. It's a local university affiliated to all the schools in that state. I did my undergrad in electronics and communication. It's similar to EC here, but it's more electronics than electrical, right? Okay, and I actually did do research in my undergrad. I worked on face recognition. So at that time, I did have the state of the art in face recognition stuff. We were competing with universities in the US. So that was fun. Limited budget, very crappy laptop, writing code. So we were using evolutionary algorithms at that time to actually outdo what people were doing with massive compute. So you can think of it as like the worst version of a perceptron. You're going to learn about deep learning today. So we're working on that bad version of that in 2009. So that's a long, long time ago. Okay. So then I said, okay, this research thing is cool. Let me do something more. Right. So I did fly from Bangalore to Philadelphia. So I went to University of Pennsylvania. Said, let me go get a master's degree in robotics. So I went there. So I said, okay, this is fun because there's a lot of robots here. There's a lot of money. Let me have some fun, right? That's honestly the story. I'm not making that up. So I did not know what research was. I just wanted to have fun. So that is how it started, right? So okay, I joined the GRASP lab. I was like, okay, this is a cool lab. It's one of the best labs in the world. Let me join it. It's fun. So the first project I worked on was this thing called U-Penalizers, which is a soccer team, right? Or football for other people in the world, right? So it's basically these now robots, which are about this tall. It's about 2 feet tall. No, not 2 feet tall, 1 feet tall. And they have to play soccer. There are 5 robots in each team, and every single thing is running on the robot itself. And this thing had a very, very, very bad computer. So it had a dual core, not even a Celeron, something even worse than that. So for people who don't know what Celeron is, it's like the worst computer you can buy. It's worse than a Raspberry Pi 2. That's how bad this is, right? To give you perspective. So we had to come up with creative techniques to actually make it work. As creative as we could not process like the entire 8 bits of information of an image. So we would remove the number of bits and actually process it. So kind of funny kind of tricks like that actually got us and we won the championship. So that was fun. Then I said, okay, let me do some research. Like this is not research, this is fun. Okay. So I said, okay, what do we do next? So my advisor at that time, Vijay Kumar and Kostas Danielidis, so they had this massive project going on, which is basically they had a big tie-up with Walgreens, so the chain, right? They wanted to put like a swarm of robots, a ground robot plus an aerial robot, to map the entire store, right? And they wanted to not just map the way the floor plan looks, but also like the objects in the shelf, right? Remember that this is 2015, where deep learning was not that big. So all this was handcrafted classical methods, right? So that is fun. So, and remember that these objects, we did not have an inventory of all the objects in the scene because there were more than 10 million objects. You cannot recognize that many. Even with today's state-of-the-art networks, you cannot recognize that many objects, right? So we had to figure out a magical way, quotes, to come up with that thing. So that worked pretty well. So we did go to Walgreens in Chicago. We showed them a demo. We got $4.2 million for that. So the Kostas did set up a company on that. That was fun. That was my first job offer. And I said, no, I don't want to do this. So got my first job offer at the end of my first semester. in master. I said, I don't want to do this. I want to study further, right? So I said, I went to courses and I'm like, okay, I want to continue doing research with you. How do we do this? Right? So he said, okay, I have this cool project going on, which is like this building, right? It's entirely made of glass. It has vertical columns which are repeating. As you will see later, if you do not know already, this is a nightmare for vision researchers because it's repeating patterns, it's reflective, and you can see through stuff. It does not work. So the goal was to build a 3D model of that thing. How do you do that? Like your cameras, your features are reflective. You can't do it. LiDAR will just go through it. How do you deal with that? You don't want your robot to run into that, obviously. So that was the goal of the project. So we started playing with LiDAR. We started playing around with so the way LiDAR works is it shoots out a laser beam. It takes the reflection and it calculates the distance, right? Like the speed of light, so you calculate. Problem is, what if the light doesn't come back? So, but there is a small little part of light which reflects because none of these are perfectly transparent. And that's what we were trying to use. But sort of worked, but it was pretty bad. So we said, okay, we gave up at that point. Said it's not going to work. So what we did is we put these like little April tags or fiducial markers all around the building. And we figured out a way to completely map that. Right? We just stuck it on the wall. We said, okay, let's figure out a way to map this. And if you see tag slam, the word tag slam, you hear this started from my thesis. Right? So that's literally how it started. We said, just took these April tags, we just stuck it on the wall. We said, okay, let's figure out a slam algorithm which works. Right? That was fun. That was hard. So a lot of sleepless nights. So that did work. So that went into ICRA, which is one of the best robotics conferences at the time. And it won the best thesis award. So that was cool. Okay. So then I said, okay, what now? Right? Like, I want to study further because this is more fun. It's getting fun and fun every single day. So I went to University of Maryland, College Park, to do my PhD. Right? So my master's, like undergrad was in EC, master's was in robotics. Guess what my PhD was in? Yes. So, okay, people are stopping already. Okay. So my PhD was in CS. Yes. So I ended up being in CS not because I was affiliated to the department, but because my advisor was there. So I did apply to EC and CS. My advisor was mainly in CS, so I ended up in CS. That's literally how it happened, right? And my first session to him was like, I don't want to take algorithms. I don't want to take operating systems. I don't like these things. And he was like, it doesn't matter. Just come work. Like, that's all we care about, right? So I worked as a part of the perception and robotics group. So I started working on something very different than what I ended up doing. So welcome. So yeah, I'm going to pause here. Introduce yourself and say one thing which you like to do apart from work. You didn't hear me. Your name and one thing you like to do apart from work.
Hi, my name is Amidesh Pandey and I like photography.
Perfect. Awesome. Yeah. No, I'm doing that for everyone. So just remember your name, right? Good. So yeah, so in perception robotics group, my first pitch to my advisor was, I want to work on, have you heard of text to image? So given a textual description, you can actually generate an image. That's what everybody is fussing about today. I was doing that then. I already got that to work. That was pretty cool. I got better results than Stanford, but I was not happy with it. So I said, okay, what do I do now? So I wanted to do that for a 3D model. Because if I ask you to close your eyes and explain to me what a water bottle looks like, you can. I wanted a robot to do that. Started doing that, did not have fun. So 9 months later, I said, this is not for me. Hi, your name and one thing you like to do. your name and one thing you like to do apart from work.
Hitanshu Shah.
And what do you like to do which is not work? What you don't have a hobby?
I do. I like music.
Awesome. Cool. Yeah. I'm just asking that for everyone, so not just specifically for you. Yeah. So I said, okay, 9 months later, I said, this is not for me. Let me not do this. So I switched to aerial robots because coming from UPenn, that was my first love in some sense. Okay, then sadly enough, we did not have an aerial robot in the lab at that time. So my advisor was like, okay, I'll give you $250,000. Do whatever you want with it. I want more back. That's the only rule. So yeah, it took us, I think another 1.5 years to get the first paper out. In the 1.5 to 2 years. And that paper actually went viral. It got caught by IEEE Spectrum. So we got about $4 million back from Office of Naval Research. So that was cool. So that funded me and another couple of students for the rest of our PhDs. Right? So that worked out. So the moral of the story is don't freak out about where you want to get to. Just do what you like. You will end up where you want to. That's the moral of the story. Right? So this course is also like that. Don't freak out about results. Have fun. Okay. So this is like a 25-30 second montage of all the stuff I've done in my PhD. Right. So in this case, you see that the quadrotor is dodging dynamic obstacles with a single camera, and same reverse it, and it can actually hit the other stuff. And in this case, your camera distances are changing to estimate depth better so that it can dodge these trees in a forest. So that's fun.
Nice.
See? And in this case, it's trying to identify the gap in the wall because it doesn't know the location or the shape. It's an arbitrary shape window. It's estimating that with just a single camera. Right? Okay. So there are a lot more stuff, but this is the gist of it. Right? And the eventual sort of end culmination of my thesis was we built an aerial robot which is the size of a sunflower, and it was capable of quotes pollinating flowers. Right? It had all the autonomy running on the robot itself. So all the stuff you just saw, this robot can do. So every single year we have gone down in size by one quotes order of magnitude in terms of quadrotor scales. And that was the goal. Right? And this went pretty viral, and it got featured in BBC Earth, Voice of America, Maryland Today, and multiple other things. Right? Okay. And yeah, shameless plug is going to stop soon. So I did win the Larry S. Davis Doctoral Dissertation Award, which is the best thesis award in Maryland. And I did win the MDPI Drones PhD Thesis Award, which is the best drone thesis in the world. So that was cool. So yeah, and apart from drone research, I also did collaborate with a lot of other researchers to work on other things, right? In this case, I want you to see the thing on the top here, and you're going to see like different color things. So it's basically saying that's a different object segment, right? And you'll see that as we are interacting with these objects, you're going to start getting shapes which are actually going to conform to the objects, right? Remember that you can recognize what these objects are, but the robots do not know that. So this is completely zero shot or novel, as we call it. So if you go to Mars and you can deploy this, and the same thing would work. This is similar to how when we were kids, we would interact with objects and actually segment them, right? That's the idea. So remember that this is where perception, planning, and control all come together, right? The stack is perception centric, but there is planning and control used to make that simpler, and vice versa, right? And that's one of the major research philosophies I have, that robotics is an embodied entity. You need to have everything together. So, okay. And this is like the more sort of core vision side. This was a 2022 CVPR paper. What we did in this is, so I'm not going to explain what enflonet means, but something, right? The idea was that we were trying to estimate camera poses between two images, right, in 3 dimensions, and which is what you'll be doing in the course as well. So it would generally not generalize across data sets. If you train it in an indoor data set and put it outdoors, it will not work. And that's like the problem with deep learning, right? Or the other way around. So we came up with a mathematical framework which would actually enable that. So this was based on classic optimization. So we took that, we made it into a network, and actually it can have the best of both worlds. And that was the whole goal of this method. So this currently holds the state of the art in pose estimation. So we've still not been beaten. It's almost a year. So that's good. That feels good. Because in Vision, you put your paper out on archive, next day it's already beaten. So this is nice. So it actually shows that math makes sense. And which is what I want to convince you at the end of this course. That math is cool. Do deep learning, but math is also required. Right, welcome. Yeah, please introduce yourself and one thing you like as your hobby. No, that's for everyone, so don't freak out.
So I am Ramanat. My hobby is watching anime. It's like one watch anime daily.
Hi, my name is Wyatt. Like we want long walks if you
Awesome.
want to go around Worcester walking, let me know.
Awesome. Cool. So then after college part, I finished my PhD there. Then COVID hit. Then I stayed back for another year there as an assistant clinical prof. So I didn't want to do a postdoc. I said, what now? I applied for jobs everywhere. Ended up being in the same school. It's okay, works, right? Like worked there for a year. Hi, welcome. So your name and one thing you like to do. No, not to freak you out, but just to know.
My name is Mihir. I like to work at anime.
Okay. Anyway,
I'm Dheeraj. I like playing video games.
awesome. Cool. Yeah, that's it. So I stayed back. So I worked with about 40 undergrads to do research. So that was fun. So that was cool. And yeah, a lot of them got into like good companies. We'll see what they are in a bit. Okay. So then I came to WPI. You heard about that. Right? Enough shameless plug. Okay, I'll stop. So one thing I want you to know is take this course seriously because it is rewarding. If you are materialistic, you will get into these places. So my students have gone into all these places. They earn 10 times more than me, and I will get you in. Like I can call them up and be like, take these kids, take these students. They will take you, right? So don't worry about that part. Okay, cool. Make sense? Cool. And so some of the cool things which my students are working on. So the Google Maps in developing countries is not developed well because Street View is not very good. So one of my students works on satellite images to that conversion. So that's happening, but that's cool. So, and one of my students works on Amazon Go. So it's the cashierless checkout system using computer vision. So that's fun. And one of my other students works on counting fishes in the deep oceans, completely autonomously, right? So then one of my students works on augmented reality, Pokemon Go, that exact product, right? One of my students works on estimating the yield of apple orchards in the Napa Valley region and for grapes so that you get better quality wine, right? Okay, and obviously self-driving cars. There are a multitude of people who work in that. So Tesla, then Ford, then Apple. Apple has a self-driving car, believe it or not. Waymo, all these companies. Cruise, right? And obviously navigating through forests using aerial robots. Right? That's exactly my research area, right? So the reason I'm showing you this is that all the stuff you learn, though it's sort of computer vision, can be applied to anything. And that's the reason I'm showing you this, right? It's agnostic to the domain it is in, and it will work in every single domain, right? So you don't have to be limited by that, and many more, right? Okay, so if you are interested in academia, so my students have also gone into these places, right? So one of my students works on finding tissue, like cancerous tissues in tumors, like with ultrasound images. That's one thing. The other student, the work you just saw about nudging was from one of my students. And another student works on this collaboration between a ground robot and an aerial robot to explore mines, right? So all these kind of things is what you can work on. Okay, so just as I asked you, I'm going to tell you a few things about me. So my name is a palindrome. It's spelled the same way forward or backward, right? So it's easier to remember. So I was born on Jan 1. So I do like traveling, hiking, and taking photos. So after every semester, I take a 20-30 mile hike. I do camp out in the mountains, come back, fully recharged for the next semester. So I generally like hiking in snow when it's like less than 0 Fahrenheit with 20 layers of clothing. So that's fun. And of course, I like taking photos, right? Cool. So I am also a professional photographer when I'm not a professor. So my photos have been bought by National Geographic or the Virginia government. And you would see all the wallpapers you see running through are my photos. Okay, and I've been to 14 out of 56 national parks, counting. So I do have a motorcycle. So I do ride for fun. So this is my Yamaha R6. It does 0 to 60 in 3.2 seconds. Makes sense that I work on aerial robots because they're fast. Okay, I do play Dota 2, like as some of you. And this was our dog when I was a grad student. So we had a shared dog. Okay, and the fun thing which I've done in the last 3 years is I've driven from College Park, Maryland to Death Valley National Park in California in 2.5 days in a Mustang. That was fun. That was hard, but that was fun. So don't do that. And I can also sort of pseudo fly planes. I'm not a pilot yet, but I can pseudo fly planes. Okay, let's get to the serious stuff. So I'm going to make it as two way as possible. It's not a one-way monologue. The monologue ends here. So I want you to start telling me, or I'll start picking people. Okay, and I don't want the same person to answer twice. That's the goal, right? So what is computer vision? The TS don't answer. Yeah, anyone. And there's no wrong answer. It's fine. Go for it.
To recognize objects.
Okay, so that's one thing, right? Like, so recognizing objects is one thing. What's the broader picture of that? Yeah.
It helps computer use the world.
Okay.
Sort of just taking any amount of the image as a feedback, as the input, and just sort of processing it in any form, whether it's identification or decision making or anything else, human be something with those QR codes.
Perfect. So like both of you said, it's basically getting some visual input. Doesn't even have to be an image. It's any visual input. It could be like a very low pixel, 1 pixel camera, which is like a light sensor. And you're going to use it to do decisions, but you're inferring some information from it, right? If it's an image like this, you can recognize things. You can sort of put boundaries around objects. You can say it has circles, all these kind of things, right? And you can sort of abstract it at any level. And that is like, if you're a bird, your abstraction is very different from if you're a human, right? So humans, you can recognize exactly what this is, the bird, maybe not. But it's good enough, right? That's the idea. What is machine vision or perception? I'm sorry, the contrast on the screen looks worse than my laptop. I'm going to change it next time.
It's very good.
Kind of mimicking what you and I can do.
Okay.
Basically, we have IMB where the system does. Similarly, in that we have a camera. We can see the input and we can process it using the processing.
You're almost there. You're missing one little part. What is that?
Integration.
Which, yes. And what else? There's one more little thing. You almost said it. Slight modification. Yeah.
Perception would be more broader, like either visual or.
Sure. Let's say what is machine vision then? Like we just talked about computer vision. What is machine vision? So just the one word has changed, right? Computer to machine. What is that difference?
And machine.
Yeah. Sorry?
All that things.
The machine? Yeah.
Machine take.
Yep, exactly. So the difference is, this is the question, right? Like, what's the difference between a computer and a robot? It's the exact same thing, right? So generally, when you say machine perception or vision, it is something which can move or has the capability to move. The computer vision is a subset of this. So you can say that a machine has computer vision capabilities, and that becomes a machine vision system, right? So the computer vision is more computer science thing. It's a more the software side, if you want to call it. Machine vision is more the system side of it. So it's the entire integration stack, right? So when you're working on a real robot, you generally call it perception, not generally vision, right? That's the small fundamental difference. People do use it interchangeably, and it's okay, but you should know what the difference is, right? Okay. So some applications which we already talked about, but so you can have like automatic data labeling, like, okay, that's an avocado, right? So you can start doing stuff like that. And you can, like on a self-driving car, you can put this thing and you can start labeling every single pixel and saying what it is, because that's useful to drive. You don't want to drive off the road onto some pedestrian. So that's required, right? And you can definitely detect brain tumors. So that's nice to have. You can save lives. And you can also build three-dimensional maps, right? Like as you're traveling in the scene, you want to know what not to hit. So you want to have like a perception around you. So you can start doing that, right? And you can also detect like poses of human beings, right? Or animals or whatever, right? Like to say, okay, is this person doing push-ups right? Is this person walking right? Is there a problem with this person's walk, right? Like all these kind of things, right? And multitude of other applications, right? So vision is everywhere. When you pull out your phone to check the QR code, that's computer vision, right? So literally every single second of your day, you are doing computer vision. You take your phone out, you take a picture, something happens in that picture, that's computer vision. You take your phone out at night and you take nightscape, that is computer vision, right? So all those things, it's the same thing, right? So just remember that, open your eyes, every time you use a camera, there is computer vision in the background, right? Okay, so now that I've convinced you that this is good, I hope, let's go more formally into what this course is about, right? So imagine that you have a scene, in this case a tree, right? And you have one camera. Let's go with one camera for a second. And it's one single camera. It's not a stereo camera, right? So you capture an image, right? So how you capture an image, we'll talk about it in the next class, but you get an image of the camera, right? And that camera is now moving. So you get a different view of the scene, right? So the tree looks slightly different. So let's put both of those images side by side. You see that the images are slightly different. Just given that information, can we figure out what the, like these two images, like the subscript just means that it's time, right? Can we figure out how this camera has moved in 3D space, right? And that is one thing you will learn in this course, right? That's what enables you to drive a self-driving car in the world, or a drone, or augmented reality, right? You're pointing your thing and there's a Pikachu on your table, and you're moving the camera. The Pikachu is also staying the same, right? How does it do that? So that is the kind of stuff you will learn, right? And you can do that with a single camera, multiple cameras, moving cameras, which are multiple of them. So you can do all these things, right? So also you can go one more step. You can throw some extra sensors on it, like your phone has an inertial measurement unit. So that's how you get the auto rotation feature to work. So it knows which way is up or down, right? So you can also use that. You can fuse that with your camera, right? And you can say, okay, like if my camera is moving really fast, the images are blurry, but this sensor can actually work, right? So how can I fuse these two complementary set of information to make this work, right? That's the goal. So you will do that. And furthermore, so of course, we'll use deep learning as every project, in every single project in this course. And you'll do some stuff like, okay, like you saw the semantic segmentation, right? Which is every pixel you're telling what it is. So in this case, I've labeled the bark and the tree. So you can do stuff like that, right? You can do much more fancier things, but I'm just showing you a very simple example. Okay, so let's meet your awesome TAs. This is Dr. Lenning Lee. He just defended yesterday and he finished his PhD. So he is an expert on, yeah. So he is an expert on optimal control, reinforcement learning, and temporal logic. So anything with respect to that talk. Of course, he is an expert on video. But apart from that, he's also an expert on multiple other things, right? Then there's Vaishnavi. She's a second-year master's student. So, and she works on facial stuff. She works on emotion recognition. So how do you make it like invariant to pose, all that kind of stuff. She's working on super cool stuff. So talk to her about these things, right? Okay. So you know where the classroom is. You got here. So I just put it there so that you have it. For people who are online, you know where to come next time. Okay.
That's good.
Cool. So mandatory warning. I'm going to make it very quick. So let's get past this and move on live. So if you are sick, please stay back. Please do not spread COVID to people. Just send me an email and we will work out what logistics we need to do. Okay. That's as simple as that. So this is the only case you will email me. And under no other circumstance you will email me. How you will contact me, we'll talk about it in a second. But this is, you email me this time. Okay. So you can also contact me on Piazza for extensions if you're out of late days. So by default, we'll talk about what late days are in a second. We have 40 minutes. Okay. So we have time. Okay. So we'll talk about what late days are. By default, if you're sick, just send me an email and you will use your late days to do your assignments. If you run out of them and you were actually sick, send me an email. We'll talk about it. Okay. So check the WPI COVID resources. That gets updated every now and then. If there is a Zeta variant tomorrow, things might change. So just be on the lookout. Just be safe, right? I hope not. Just be safe. Masks are optional. And if you're welcome to wear it if you want to. So if you want me to wear it and you're uncomfortable, let me know. I will wear it. So if not, I won't. Okay. So, okay, there are 3 places where you'll find the class resources. So I'll make it as simple as possible. So RBE 549.github.io is where it will read out you to my website. That is where the class web page is. Right? Just bookmark it and put it on your phone or your laptop, right? Just make life easy. So this is where all the assignments and everything will be posted. We'll talk about that in a second. And then there's Piazza for discussions. So use this exclusively for communication. Between you and the TA or you and me, this is the mode of communication, right? And I'm going to post these slides anyway, so don't have to worry about it. So Canvas is where your grading will happen, right? So all your official submissions and grading happens to Canvas, nothing else. Your announcements are also going to move to Piazza soon. I'm only using Canvas for the first 2 weeks because students are enrolling every single day. Once that is settled in, I'm going to only switch to Piazza. So just, if you're not enrolled yet, please self-register. I do add students every now and then, take the updated list, but if not, you can just self-enroll and it works. Okay. So like we discussed, the assignment, deadline, and other instructions about the project and everything will be on the website. That's the one-stop shop for everything. So use Piazza for communication. That's your only mode of communication. So if there is a medical emergency, you can email me. That's my email. And use the tag in the square brackets, literally put that thing so that it pumps up in the queue, right? Or else I might miss your email. So please do that. Right? If it's for my convenience, not yours, but I will miss it. Okay. So, and Canvas is used for all grades like we just discussed. That's easy. Okay. So again, one last time, use Piazza. Right? I'm not going to say this again. One last time. So use Piazza because that's the easiest way to get through me. Right? So I have a separate filter for Piazza. It puts it on the top of the queue. That's the reason. Right? So because if you send it to me on email, I get 100 emails a day. It will miss out. This is better. And do not email your TS. This is the only way you communicate with your TS as well. So I've told them instructions that if they get an email from a student, they will delete it. If it's not regarding health issues. Right? Any doubts? Piazza is the way. If it's taking us to respond, have a little patience. And if another student knows the answer, please reply. The idea is that you should help each other. I have not kept points for Piazza participation. It's a little cheap. I'm not going to do that, but do help each other out. Right? That's the whole goal. Okay. So again, this is the most important thing. That's why the entire thing is in red. You should not email any of us about grades. That is against the university policy. That I'm strict about. Right? If you have issues with grades, come to us, office hours, or you can use Piazza. Use a private post, and it will reach us, and we will talk to you. Okay? Make sense? And do that ASAP. Like once you get the grade, don't wait for an entire semester to come back to us. Not at the end of the semester. Like if they post your grade, like 2-3 days is a reasonable amount of time to get back. Right? Okay. So, and of course, you can fix an appointment if you want to talk to me or them about anything. You can just send them an email, send them a Piazza post. You can do a private post, so that works. Right? And if you're interested in my research, this is the place you email me. This is the place you email me, right? Because so that it's a separate thing, so it's easier for all of us. Okay. My office location is in Unity Hall. It's 250E. It's like when you start walking in, it's the edge, the last room where there's a glass door next to it. Right? All doors are glass, but there's a door next to it. So you'll find it. It's not that hard. So my open office hours, like with respect to anything you want to chat about life, you can show up 3 p.m. to 5 p.m. on Tuesdays and we can chat. If you need to talk more about the course, send me a Piazza post and then we'll fix the time, which is longer or something. Okay. Okay. So I don't call it class rules, I call it house rules because I want you to treat it like that. Because this is one entire family, right? And I want you to respect each other that way, right? So that's the first rule. Second rule is you have 7 late days. So what late days mean is that, okay, say the deadline is tonight and you want to submit tomorrow. So even if it's 5 minutes late, right? You're going to submit tomorrow. You're going to use 1 late day, right? So you have no penalty for that. You have 7 of those days and you can use it as you want, except for 2 conditions. You cannot use late days for midterm, which we'll talk about in a second, or the final project, because I have to give you final grades at that time. Okay? Those are the only 2 conditions. You're allowed to use late days for homework 0 also, obviously, right? So you can. But no other case, you're allowed to use late days. And if you run out of late days because you were sick, send me a post or an email, we will talk about it. So then if you run out of late days, every single day, you lose 25% of your grade. If you submit 4 days later, what happens?
Please. Yeah, all around it.
Don't submit. Yeah.
Oh, that was that from what curious. Is it 25% of what the grade you would have received?
No, it's minus 25. It's minus 25. Yeah. It's 25% of the maximum grade. Yep. And all the assignments are going to be scaled to 100. So, yeah, good question. So, yeah, so you lose 25%. So if you submit 4 days later, it's a 0. Right? It's not a decay. It's a flat. Yeah. No cheating. I have to tell you this. I'm assuming that none of you will cheat your grad students. It's pretty serious. This is one thing I have no tolerance about, apart from COVID guidelines. I will throw you out of the class. I'm being very serious about that. I will not give you a warning. I will throw you out. I will give you a straight 0. I'll fail you. So do not do that. Okay, so follow submission guidelines. So the files are named in a particular way for a reason. Please do that. If you have doubts, ask us. It takes 2 seconds to send us a post and ask. Just ask. So just follow that. Okay. You might be like, this is so strict. The reason this is strict is because when you work in a company or in a research domain, your file naming is important. This is teaching you that. So do pay attention to that, right? Your papers can get rejected if you submit with the wrong file name. Your company code base can break if you push with the wrong file name. That's why it's important. Okay. This is a no whining zone. So what I mean by that is that the course is hard. It is expected to be hard, right? I'm not saying we will not offer help. We will offer help. We're all here to help you anytime you want. But you should know what you're getting into.
Should, yeah.
This course is going to be hard, right? And it's going to be harder than any course you take here. I will promise you that, right? But it's going to be the most rewarding also, right? It's the cost you're paying. The time is the cost you're paying for learning that much, right? So this course has about 1.5 to 2 courses worth of content, which you would learn in another university. And that's why it's hard. It's not to make your life miserable. It's to make you learn more stuff. Okay? So again, 0 tolerance to plagiarism. Because I know that like when things get hard, you would resort to wrong things. Don't do that, please. Come talk to us. We are here to help. So just come talk to us. Okay. Obviously, we just talked about it. Okay. So yeah, the ideology of the class is very simple. It's basically how do you implement things from scratch? Right? It's not taking a piece of code which is available on opencv.com and just running it. How do you get there? That's what you're learning in this course, right? So it's basically math to code and code to math. You will read a lot of code. I will not call that plagiarism because you should read code. You should read other people's code to learn how to do it better. That doesn't mean you put one screen here, you're looking at their code and you're typing the same thing. That is still plagiarism. It's not Control-C, Control-V, but it's still plagiarism. Does that make sense? Read code, understand it, put it on your own code base, right? That's okay. Don't take it and put it here, right? So that's the thing. I know that all of you will see code. I know all the codes you will also see, because I've also gone through that before I design. So just know that I know where you will see the code, right? And I'm actually going to give you the links where you can see the code also. So I know that you're going to go there. So I'm going to show you how many things I know where you can find these answers. But again, like I'm going to treat you like adults and just keep trust that you'll not just copy paste from there, right? That's the whole goal. Okay. So failure in this course with regard to not getting outputs is common. Don't freak out. It's okay. It's hard, and it's all right? So I call it path to success. It's not failure. So you're going to get there eventually. It's not going to work 100 times. Your code is going to keep breaking. It's going to have a seg fault or whatever. You're going to hate it. That's fine. Don't freak out. Calm down. You'll be okay. Okay. So I just had to put an inspirational quote there. I'm going to skip that. Okay. But please don't give up. Right? So if it's getting hard, just ask. That's all I'm saying. Right? Okay. So I highlight the word conceptual here. That is important because the help you're asking should not be how do I put this in code. It should be like, I don't understand this concept. I do not understand this equation. Help me out. That is fine. We will do that. You do not know how to derive something, we will sit with you, we'll derive it for you. But if you say that, okay, this Python package is not importing, we are not going to help you there. That's for you to figure out. Remember, it's also cross-listed as a computer science course. It's a grad computer science course. You're expected to know how to program. It's not a programming 101 course, right? So we're not teaching you that. So, like I said, instructors will not debug code. As they get the same thing from me. They will not debug code. Instructors will not fix your computer. We are not IT support. And IT support will probably also not fix your computer because they are too busy, right? So the good thing we're going to do for you is we are also going to have a cluster set up for you after homework 0 because we are still working the details out. You can log into that. Things should work out of the box. You don't have to install any package. Everything should just work. The only catch is you don't have a GUI. So you just have to do everything in terminal. So get used to that. So like any big cluster, you do not have a screen attached to it. You're going to like log into that and use it. So Learning will probably, or Vaishnavi will have a tutorial session or whatever we will call it. So to teach you how to use that. We'll get there eventually. Okay. So, and I understand that all of you are taking more than one course. So please manage time. Do not put this course in the last second. The project will not work. Start on the day it's given. At least read what is going on so you know what is there. Come to the office hours and show up. And like, even if you're sitting there and other people are asking questions, you know what things can go wrong. That helps. So that's a philosophy you should cultivate. Just show up, right? And that's the first thing I told them. Like, you'll have like 50 students showing up to your office hours. So get a bigger room, right? I'm being very serious. Like, make that a habit. Just go. Just show up. Right? At least 1 office hours a week. Just show up. Right? Okay. And obviously, it's easy to fall behind. So please submit things on time. I think we just talked about. Okay. Okay. Any questions with logistics? I know it's a lot of information. So I'm going to take a break. So any questions you have? Yeah.
So when you say this course is going to be the hardest one, so do you recommend taking to other courses which are lighter?
That's up to you. It's about how much compromise you want to do on sleep. Right? That's the honest answer. So to be honest with you, I think it also depends on the background you have. So if you have a good enough solid math background, this course is not hard. Right? That's the thing. So like this expects pretty strong fundamentals of linear algebra. And if you have it, you should be okay. I will do my job as best as possible to teach you every single concept. I will not teach you how to code. I will teach you all the concepts you need. Slides will have almost all the math you need to put it in code. It's not going to be a one-to-one map. You still have to understand what is going on to make it work. But mostly it will be there. Right? So you probably will not need any textbook if you have the slide deck. That's the goal from my side, right? To make that part easy. The part which is hard is the debugging and the programming part, because there is going to be a lot of it, right? So that part is going to be hard. And that's how it's designed. Make sense? And it's a hands-on course. Like it's going to be very, very hands-on, right? So yeah, any other questions? That's a good question though.
Good.
No questions? Yeah.
Have a class on Tuesdays from 3 to 4:30. So they can most of the robotic grad students would have it.
Oh, it's the same. Oh, so it's like 500. Okay, I'll try to change it. So what? So you also have a 5. Okay, let me figure it out. Okay, we can do it. That should not be a problem. That's a minor change. Yeah, another thing I can also do is I can hang out after class. Here, you can ask questions. That's easy. I don't think there's any class after that, so we should be okay. So we can also do that. Okay, cool. So any other questions? I skipped ahead. I mean, you should ask questions. That's the whole point. Yeah, I want you to know what you're getting into, right? Then it's going to be a fun journey, right? Like it's a roller coaster ride. Yeah.
With the assignments listed on the website, have you not posted the second term's worth or the second term mostly?
We'll talk about it in 2 minutes. Okay. It's on my slides. Good question. So like it will be posted by the end of this week. So all of them will be updated. Yep. So I was just having a chat with them today morning. So yeah, we were just deciding. Yep. Yeah, because everything relied on the cluster access, because that's the bottleneck right now for us. Because most of these neural network stuff you cannot run on your laptop. If it was not the cluster, we were seeing, okay, can we do Google Colab or something like that? That's what we are trying to figure out. Yep. Yeah, any other questions? No? Cool, let's move on. So you have a total of 8 assignments. I will split it to what they are. You have 3 individual homeworks. So homework 0 is one of them, right? There are 2 more homeworks. So you have 4 projects, groups of 2. Start looking for a group partner. I expect you to not change it during the semester because that's a nightmare. So please pick your partner wisely. Okay, that's one thing. So like Monday is going to be project 1 release. So have your group ready before that. Okay, good. And that's going to be mostly programming. So that's why there's a programming symbol there. Homeworks will have a mixture, programming and some math maybe. And the midterm exam is going to be purely math. And it's a take-home exam. Most likely you'll get either 5 days or a week. So open book, No discussion. Use whatever you want on the internet. It doesn't matter. Right? That's the goal. I want you to solve it. Right? That's going to be hard. Don't freak out again. It's okay. So just do your best. It's some of the questions are open-ended.
Thanks.
And that's fine because there is no wrong or right answer. It's a research problem. So I just want to see how you think. And that's the goal. Okay. So as I'm hoping all of you have at least seen homework 0, if not started. Okay. If you have not read the entire thing, there's a report also expected at the end. If you have not seen it, now is the time, not now. Like after the class is the time to go check it out. So, oops. Oh, I forgot to put an image. Okay. Anyway. So basically it's supposed to be like a conference quality paper. So it's like a 4 to 6 page report in double column IEEE format in LaTeX. Has to be in LaTeX. You're not allowed to use Word. I want you to learn LaTeX because you'll thank me later after the semester is over. You put it on your website, you will get interview calls from wherever you want. That's the goal. So it's teaching you also these soft skills, not just computer vision, right? So if you do not know LaTeX, use Overleaf. It's relatively simple. And if you have it on your local machine, that's fine. Okay, cool. Any questions with that? So I also have like sample reports on the courses I have linked in the future slides. So you can open it and you can see the quality, so get an idea. Okay. So coming back to your question. So homework 0, you obviously know what is going on. So project 1, like I say tentative to all of these things because they're subject to change a little bit, but conceptually more or less will be the same, right? There are logistics which are being figured out. So the first one is panorama stitching. So you're going to automatically stitch panoramas completely in a computer vision manner. You're going to do that classically and in a deep learning manner, right? Second project is face swap. So what Snapchat filter does. So you're going to swap 2 people's faces and classical and deep learning, right? And homework 1 is autocalib, which is you're going to figure out how to calibrate your cameras by taking pictures of a checkerboard. You're going to implement everything from scratch. So whatever OpenCV checkerboard calibration toolbox does, you're implementing that paper, right? Next, so project 3 is structure from motion or SLAM, as all the robotics people want to call it. That's what you'll be implementing. So single monocular camera moving, how do you actually sort of build a 3D structure and estimate the pose? That's what you're doing, right? And obviously we have to do some neural network stuff, so we'll do a NERF project as well, right? Cool. So what NERF is, we'll talk about, but that's the deep learning version of SLAM, right? So then there'll be a homework 2, which is you have LiDARs and you have a camera and you have the semantic segmentation which you want to bring it into the LiDAR space. So if you want to remove a car from the 3D point cloud, how would you do it? Things like that. It's not that hard, right? Third project is going to be the hardest because it's the most, quotes, non-vision like. So it's visual inertial odometry. You're going to fuse information from a vision and an inertial sensor to estimate 3D pose. So like your phone, like you're running with your phone, your images are blurry, but your IMU works pretty well. How do you fuse that to get the pose? That's what you'll be implementing, right? Cool. Midterm exam, like we mentioned, it's going to be theoretical, take home. So that's it. Any questions here? I'm not giving you the details because half of it is tentative, but that's the general idea.
Because for the reports, I get quickly to give the equations and figure out what we have done, or just like the flow of the code on the.
Good question. So there are 2 ways to do it. So my rule of thumb is anything you can write an equation, do it. Anything you cannot write in an equation, put a pseudocode there. Like some of them are just algorithms, right? There's no math. So that's fine. But you don't have to write every single thing. Don't write how stochastic gradient descent works because that's a built-in package. Anything you came up with, definitely put it there. So for example, for the neural network stuff, you'll have the architecture, right? So put an architecture diagram. Right? We'll talk about that in a second. Any other questions? Yeah.
We have a kind of reflection on the assignment.
Yeah, so there's a deadline.
No, I mean like running time.
No. It can take 2 days. It's fine. Yeah. You're not being graded on your code cleanliness or the speed. Yeah, it's like the slower you make it, the harder it is for you to debug. That much less time you get. But yeah. So we don't, yeah. We don't, right? We don't, yeah. So yeah, okay. So So I am a TensorFlow fan, but I switched to PyTorch because everybody in the world is moving to PyTorch. So we should probably move to PyTorch as well. So we are going to be using PyTorch in this course. All the other packages are pretty standard. And majorly everything is based around Linux, specifically Ubuntu 2004. So, and Python 3.9, I believe, is what we are on. So yeah, these are the standard things. Like, there's nothing new here. Okay. So I don't call it textbooks, I call it reference books because most of the content you get are from the slides. But if you want to go into the derivation of most of the stuff, I will not derive everything in class because there's no time. I will explain to you how the steps work. So if you want to go into the math, actually understand and derive, you can check these books out. It's in that order of preference, right? So with the classical 3D vision stuff, it's the first two books. Then the other image processing kind of stuff is the middle two books, and the deep learning is the rightmost book, right? So most of these are available in WPI library for free on the internet. Like it's an ebook, so you can download them. And most of them, authors have made the books free, so you can download them and just read it. I would not ask you to buy them. It's too expensive, right? So just get that. Okay, so most of the solutions for your projects will be here. Look at them, that's fine. Don't copy, right? So I'm putting it out there so that you can definitely refer to these things. Not the solutions, but like refer to the slides because they will have a different perspective of explaining. You might find it better than mine or vice versa, or maybe combining both is better. So that's okay. So most of these projects have been modified heavily from these courses, right? So you can take a look at all these courses, right? And obviously I would want to thank all of them for making their courses public so we can actually have a better course, right? Cool. So office hours are here and we're going to change that. So my office hours are going to change. Linux office hours are Monday and Thursdays, 3 to 5 p.m. Vaishnavi's is Wednesdays and Fridays, 2 to 4 p.m. Right? Location is going to be declared, so they will post on Piazza, so it will come soon. My office hours are going to be in my office as of now. If there are more students showing up, we'll change that. Okay?
Yeah.
Cool. Any questions? We have 17 minutes. So before I talk about homework 0, any questions? Yep.
Yeah, upload these slides.
Yes, I will. After I finish the class, I will upload it. Yep. So I will try to upload the slides next time before I come to class. I forgot, so that you can actually annotate notes on it if you want. So that's the goal. So yep, good question. Anything else? No questions?
Not that one. I got not being sure. It's a bit done.
Okay, cool. So this is due on Sunday, this Sunday, right? It was supposed to be due on the first day of class, but that's okay. So I'll tell you what the expectations of homework 0 are. It's very simple. You're expected to know this before you come to class. So yes, you can ask for help where you don't understand what the project is about or homework is about, but preferably not technical help. You're expected to figure it out on your own. That's the goal of this homework, right? Because if you do not have background, this is the way to gain that background.
Take cheap.
Right? Make sense? So is that clear? Good. So do not email us asking if things don't work.
No.
Sorry?
So what did you say? If you do not have the background?
If you do not have, you are expected to figure this out for your background. Yep. If you do not have the background, reconsider this course.
Okay.
Like, it's for both of our good. Right? You take it again. I'm not saying don't take it again. It's just, if you don't have the background, just do other courses, come back. Right? Like either math or programming, whatever it is, right? But you can figure it out. If you can figure it out in 2 weeks, this is 2 weeks, right? That's fine. Like I will never say, okay, you don't have this listing on your profile, so no. That's why this is there. So if you can solve it, that shows me that you figured it out. That's all I care about, right? Okay. So homework 0 has 2 parts. So first one is shake my boundary, whatever name. Okay. So imagine that you have an image of an airplane. If I ask you as a human being what the boundaries are here, you'll probably only outline the airplane, right? You're not going to outline every single cloud there, because it's weird. But if you run an edge detector, it's probably also going to outline a few clouds here and there, right? So, and here obviously the brighter it is, the probability of it being an edge is higher. So the dimmer it is. Obviously it's dimmer, but you still don't want that. You cannot always just say, okay, all the darker edges are better, right? So we would want to do something better than that, something like this. And this is what you're implementing, right? How you do that, I'm not explaining. I'm just going to show you an overview. So you're fusing three things. You're fusing color, then you're fusing filter responses and edge responses. So you fuse all three, so you get a higher order information, right? So you see how texturally it's similar, how color-wise it's similar, and how actually the other boundary detectors work. And you fuse all of them to get a better boundary. That's the goal, right? There are deep learning versions of it, which do it today. Life is easy. But I want you to learn this classical way so that you know how to make that deep learning network better. That's the reason you're learning this, right? Because, yeah.
No, and as you said that we are fusing and we are getting out best highlights now, equity, let's say. But if I just do Sobel and carry, I do probably get more edges. And so what all I'm doing after the entire compute that I'm putting into is I'm just reducing the noise probably.
Yes.
So how do I say that, it really has an application as compared to Sobel or carry?
That's a great question. So I'll answer that question because that's a very good question. So I'll tell you what it is. So with a Canny or a Sobel detector, right, you're tuning your thresholds manually. I take a slider and I go left and right, every single image. I have 1 million images. I'm not going to do that. And that's just too hard, right? So you can tune it to be very sensitive for a particular image. You can tune it to be very insensitive for a particular image, right? That's fine. It works pretty well, but it's hard and it's painful and it's manual labor, right? If you're doing this with Amazon Mechanical Turk, that's a lot of money. You don't want to do that. So you want to build automated tools which do that for you, and this is what that is. So yes, there is more compute. You're trading off more compute for human labor. That's the goal. And obviously we can have GPUs. This is not GPU accelerated, but if these are GPU accelerated, you can actually make it faster, right? So think of this as you're using this to generate boundaries for images, which you train a neural network on, which will make it faster for you. So that's the way you would actually deploy it. So like if that was your question, how do I deploy it? That's the way you deploy it, right? But this is just giving you that ideology, okay, think about it this way, right? That's the thinking process I want to imbibe in you. Make sense? Okay. So second part, yeah.
In the case one itself, like when we calculate the texture, again, there's so many filters, right? And also we have most of the I found they're slightly similar, right? Like if you do the first order derivative, second order derivative, it's and on top of that, you're also reducing the dimension. I don't really understand if that's great information.
That's a beautiful question. So the question was like, we're using so many filters. The responses are pretty similar because they're all first and second order. Yes. The answer is yes. The reason you're implementing so many is to learn. That's the honest answer. And even if you use only one filter bank, you will more or less get the same results. But I want you to learn all those filter banks because they have their own utility in different cases.
No.
For you to learn. Yeah. As and I'll include myself. So yeah, it's for you to learn so that you know how it works and why it is that mathematical formulation. So you can use it in the future somewhere else. Yeah, there was another question here. Yeah.
Is there any place where I can find the lectures or mathematical brains the I could do?
For the filters or? The filter banks, I think I have linked a few of them. Like the Leong Malik filter is linked in the thing. The Sobel filter, they have a Wikipedia page. So, and I think, what was the other one? The Schmidt filter also has a Wikipedia page. So, yeah.
There's one more thing that I was reading the Giver Filters Wikipedia page, but the filter that I was expecting is not what the Wikipedia reference board gives me. So I found out a new realization of the same Giver formula. So if I use it, so obviously I'm referring to something and probably implementing the same formula. So do we consider that as plagiarism?
No, as long as you understand it. If you, like I said, you open it on your screen and you just copy paste it, no. If you really understand the math, I'm okay with that. I mean, obviously, you implement the code, it's going to look the same, right? There's the same equation.
I cannot really.
No, of course. You're not creating new math. No, that's okay. That's all right. I mean, see, here's the thing. You need to understand one thing. For three of us, we'll know when something is plagiarized. It gets serious. First thing is we'll call you to our office and we'll say what happened here. So that's going to happen. So you'll know. So don't worry about it too much. I think just understand. The honest thing is like you need to be really honest about it that you understand what is going on, right? So you will look at code and that's okay. That's how we all learn. We do look at other people's code who have done something better than us and we learn some trick there. That's fine. So if you look at the starter code, it's pretty bad, right? If you noticed, yeah, it's pretty bad because we made it deliberately bad so that you cannot plagiarize. And it does not have classes as well as it should, and so that it's easy to understand. So that's the reason. The code is going to get progressively harder as the course gets on. You'll see that progression also. Okay. Any other questions? Yeah.
If we figure out contour construct the kernel of computer, how they use CV to like function to apply.
No.
So we have to manually like create the over.
So yeah, you're allowed to use CV2 functions to debug if you want, to fix your code, sure, it's fine. I'm not going to stop you from doing that. But what you submit should not have a CV2 function in it. Yeah.
We think that side by side we can use the convolutional function for not.
Yes, conversion function is fine, but like applying filter when you are creating the filter through OpenCV filter banks, you cannot use that. If you're just using the convolve operator, that's fine. I mean, it's just a multi.
If there is no to the convolutional operator is no I, so could we use another operator? Put on the side by the code to the side by.
Sorry, can you say that again?
So there is actually no from the operator in no has a
Okay.
from another library.
Yeah. Anything which is, so here's the thing. In this code, there is a big bunch of imports, right? Don't change that. Don't add to it. Anything in that is okay. As long as it does not implement a part of your assignment directly. That's the rule of thumb. If you're in doubt, just ask us, but that's the rule of thumb, right? If there is, so there is a function in OpenCV which gives you a Gabor filter bank, do not use that. There is a function which makes you apply it using convolution, that's okay. That's fine. I'm not checking you on that, right? Okay. We only have 8 minutes left. Okay, I'm going to quickly run through this, then I'm going to, yeah.
So we can use the OpenCV functions that are not implementing the filters, right?
So what are you referring to? It depends on what you're referring to, yes.
Okay, so basically I'm using OpenCV function 248.
That's fine. That's okay. Yep. So use that. It's not a problem. Yep. Cool. So I'm going to quickly run through it in 2 minutes and then I'm going to give you time for questions. Okay. So that we run through this. So this is a data set called CFA10. It has 10 classes, right? Like airplane to truck. You can read the classes and it has 10,000 images of each of these for training. 5,000 images of each of these for training. So 50,000 plus 10,000 for testing, right? And the idea is that given a new image, which is similar looking, it's a 32 by 32 image, right? So we want to identify what it is. That's it, out of these 10 classes. Give it another image which is not on this, it'll give you some garbage. But any of these things, it should work pretty well, okay? So you're going to implement a classic neural network first, just to make sure the code works. Then you're going to implement a ResNet. You're going to implement ResNext, and you're going to implement DenseNet. That's where the class starts. It's going to get harder from there. This is the minimum expectation, right? So you need to know how to implement that. So I don't expect you to know how it works. I expect you to know how to implement it.
Written from scratch, right?
From scratch is you're allowed to use layers.
Right.
Yeah. But so if they call that from scratch, it's from scratch. Yes. You're not doing W transpose X. And you are not allowed to use Keras ResNet. That's what I mean by scratch, right? Yep. So as I'm making it clear. So you're allowed to use Contour, you're allowed to use batch norm. All those things are cool, right? Cool. Any other questions here? If here's the slide deck, then I'll give you time for questions. Okay. So yeah, next class we'll talk about why this thing is important. And we'll play a little bit of games. So we're gonna have fun. So yeah, questions with respect to homework 0 or anything else? Yeah, I think 6 minutes. Yeah.
So as I have made a discussion on Piazza, it's very clear that what do we do with suppose the code that you have provided for taking the neural network? It's kind of fill the blank, right? But suppose if I run into a problem where I am getting some answers, but I'm not really satisfied with how it works. But again, when I'm reading the code, and I have not read it, so I really have to sit and figure out what and where is going. And if I don't understand what is happening in the code as per what you, so what do I do?
You ask us.
Okay. So because you said that you won't be giving.
So here is the thing. Okay, I'll make it very clear. So you ask us if you don't understand our code, but we hope that you do. If there is something blatantly weird, ask us. I think that's fair game, right? Because everybody has a different coding style, and you have deliberately made it bad. I'm being serious about it. You've deliberately made it bad so that it's hard to plagiarize. That's the main reason for it, right? And it's okay if you do not understand code because it's a bad code, and that's fine. They're here to help you. If they can't help you, I'll help you. So that's okay. I mean, they should be able to. They'll be fine because they wrote the code. So yeah, I copy pasted it. If I miss something, then it could be my issue as well. But it's okay. They should be able to fix it for you. So yeah, it should be all right. I mean, it shouldn't be too bad. Yeah. Any other questions? Yeah, you can ask live questions as well if you want. That's fine. It doesn't have to be serious class stuff. Yeah.
To give you like the environment requirements about PIC3 to make you in it.
So there is a README file. You can put it in that, but like you're not allowed to use anything extra apart from whatever the imports are. So as long as those imports work, your code should work. That's the goal. Yep. Environment shouldn't matter, right? Like, because if you're running it in pip and they are running it in conda, as long as the import functions work, it will work. That's the goal. Yep.
So in some of the links that you shared, there is some code already there in. So are we allowed to use that code, or we like to understand it just like us on work?
Like I said, like I know what you'll Google, so I'll give you that link already.
Okay.
So that means don't copy from there. Yep. There was a question here. Right? No? Okay. Any other questions? Okay. Any other? Yeah.
What are your next plans for your research? That would
Great question. So that's a fun question. So I'll definitely be working on two main things. So one is how do you have a swarm of aerial robots navigate through cluttered environment quickly? Second thing is how do you make a single agent fly through speeds which you cannot imagine? So 100 miles an hour, 120 miles an hour. But the catch is the robot is this small. So how do you do that? That's my research area right now. Yeah, so it's the vision plus planning plus control, all of those things. But mainly vision centric. Okay, I think there was another paper which I want. Yeah, next class. You can see more about my research. So we'll play that fun game. So I'll show you my research. I want you to tell me how that research works. And you'll start off bad, and as the course progresses, you'll know exactly what I work on. I will not tell you the answer. You will figure it out. That's the goal, right? Any paper or any video you see, you should be able to tell me what is going on inside. So I test drove a Tesla just for fun, just to see what their vision stack is working on. So I made a list of things I think they are working on. I called my friend up. And he was like, yeah, that's exactly what we're doing. And that's cool. That works. That is fun. So yeah, it's okay. That's my microphone thingy. Give me up 2 minutes. Okay, yeah.
Is Cohort 0 be done in Windows?
Yeah. So homework 0, I'm cool with you doing it however you want. But eventually it has to run on Linux. Like it doesn't matter how you develop it, right? As long as your Python code works in their Linux environment, it's fine. So, yep. Yeah, that's a good question.
According to the stack.
Yeah, like I personally use Windows Subsystem for Linux for development. That works. If you're using Mac also mostly works. Like Python stuff directly works. The PyTorch stuff will not work on GPU, but otherwise it's okay.
Yeah, just to be aware that for like some projects, the project takes a little longer to train.
Yep.
We encourage you to go.
Yep. So the nerve papers and all those things, even on the cluster, takes about 24 hours to train. Please do not do it on your laptop. It will kill your laptop. I mean, I have a 3070. It does not work. So don't do it. So yeah, like very seriously, don't do it. Like don't kill your laptop. Yeah.
How important is how the report is written as opposed to our communication?
Very important. Very important. As important as the code base. Yep. So we're graded on both equally. So it is as important as the other one. Yep. There was a question here?
My code during the lecture.
Can you say that again?
Like, do we need to bring our laptop every single time?
No. Bring your phone. If there's a survey, you can use your phone to fill it in. No. You can bring your laptop in if you want that. No. I will probably, if I need you to do something, I will tell you before. It's not a surprise.
But I mean, like my environment is set on my phone desktop.
Okay.
I'm very